Imagine that on our planet, there are places where huge masses of water touch, but do not mix with each other. From the surface, it looks as if an invisible line has been neatly drawn across the ocean, separating light water on one side and dark water on the other. In underwater caves, divers often observe something that resembles a real underwater river. Some mistake this boundary for an air bubble and get disoriented. And on the ocean floor, you can find lakes that fish swim into only one time in their lifetime. What is amazing is that these are far from rare natural anomalies or optical illusions. These invisible partitions exist in reality right now, from the Amazon to the Arctic, from river mouths to flooded caves. And the deeper I dove into this topic, the more I understood that water, which is usually considered the simplest substance on Earth, follows rules that most people do not even have a clue about.
If you look at a world map, it might seem like all the water on the globe has already mixed together long ago. Rivers flow into seas, seas are connected to oceans, and water currents have been moving around for years, crossing half the planet. Logic tells you that over time, all of it should inevitably turn into one uniform mixture. However, water is actually much more complex than it seems at first glance. Even the slightest change in dissolved salt content or a temperature shift of a few degrees can radically change its properties. As a result, one type of water can literally stay on top, not mixing with another. If you want to see this process at home, you can try carefully pouring oil into a glass of water. The liquids will touch, but they will not become a single substance. Of course, in nature the process is much more complicated, but the basic idea is so similar, it is striking. The key player here is density. Denser water tends to sink to the bottom, while less dense water stays on top. Then, if no external forces interfere and no active mixing occurs, such a boundary can last for a very long time. Most often, it's the differences in salinity that create this effect. Salt water is heavier than fresh water, so when they come into contact, they don't immediately form a uniform mixture. An intermediate layer, known to scientists as a halocline, often appears between them. Although the word itself sounds pretty complicated, this phenomenon has been occurring in nature for millions of years. It can be found in oceans, large lakes, fjords, river estuaries, and even in flooded caves. Basically, it's a boundary between waters with different levels of salinity. However, you can't always see this boundary with the naked eye. Sometimes it's hidden underwater and only shows up with the help of technical instruments. But other times, it looks so impressive that people travel great distances to admire this phenomenon with their own eyes. One of the most popular natural spots is located in Brazil. This is where two major rivers, the Rio Negro and the Solimões, converge. Photographs of this phenomenon are so unusual that many people, upon seeing them for the first time, mistake them for a Photoshop job. For many miles, one dark body of water flows right alongside a light one. An almost perfect dividing line can be seen between them. It's as if someone split the river into two parts and forbade them from mixing. In reality, there's no magic here. It's just that one river carries warmer and slower water, while the other is cold and fast. The difference in their properties is so significant that the process of them mixing happens very slowly. However, the rivers in Brazil just scratch the surface of this story. There are places ahead where the boundary between waters becomes even more amazing, and at times, genuinely frightening. A similar phenomenon can be seen in India, in a place considered sacred by millions of believers. That's where the waters of the Ganges and Yamuna meet. From a boat, you can see that one river looks murkier, while the other is noticeably darker and clearer. The local boatmen have long turned this boundary into its own attraction, and before pilgrims perform their ritual bathing, they often point out the spot where the two rivers flow side by side, as if they're second-guessing whether they want to finally merge into one. But rivers are just on the surface. What's much more interesting is what happens where an ordinary person would never look. Because underwater, the boundaries between different types of water look almost like a supernatural phenomenon. When I first saw footage from some underwater caves, I thought it was a video editing mistake. Everything is so unusual that it seems like a separate river is flowing inside the cave, complete with its own banks and channel. Actually, there is no separate river there at all. The upper part of the cave is filled with fresh water that got there from rainfall. Below that lies the heavier salt water, which slowly seeped in from the coast. A boundary forms between the two layers of water, which in some cases looks like a thick fog. It conceals the lower layer so well that it gives the impression of a real underground river flowing away into an unknown darkness. These phenomena are especially well known on the Yucatán Peninsula in Mexico. There you can find a large network of flooded caves and cenotes, connected to each other by underwater passages that stretch for dozens of miles. In some parts of this underwater system, the boundary between the water layers is very close to the surface. For divers, this means that after descending just a few feet, they enter a completely different world where the water behaves differently. When a person crosses this layer, the water around them suddenly becomes cloudy. The outlines of objects become blurry. The mask remains clear. The gear functions normally, but it feels as if your vision has worsened in a matter of seconds. The reason for this is that light refracts differently in adjacent layers of water. As long as the boundary between them is still, the view remains relatively clear. But as soon as it's disturbed by the movement of fins, the space seems to turn into shimmering, wobbly glass. For someone who isn't prepared, this sensation can be pretty unsettling. Imagine you're deep underground. It's completely silent all around you, and the world in front of your eyes suddenly starts to lose its sharpness and shape. Sometimes an even stranger effect occurs. Due to the peculiarities of light refraction, some divers momentarily mistake the boundary between the layers for an air pocket. The brain perceives one thing, but reality turns out to be completely different. Mistakes like these become especially dangerous in extensive cave systems, where proper orientation depends on practically every foot of visibility. All it takes is losing your spatial awareness for just a few seconds for a very serious situation to develop. Nature has also prepared another unexpected surprise. In some cenotes, a person suddenly feels the water around them get warmer, as if someone turned on an underwater heater. the difference is pretty slight, just a few degrees, but your body feels it instantly. After the cool layer near the surface, the transition feels almost like sinking into a warm bath. And that's just the tip of the iceberg when it comes to the weird stuff. In some Yucatán caves, right on the border between the layers, formations take shape that had scientists stumped for a long time. These formations hang down in large clusters and look like bells. Some of them grow to be as tall as a grown man. Under the light of a flashlight, the whole scene looks so strange that it's easy to see where the grim nickname, the Bells of Hell, came from. The longer scientists studied places like these, the clearer it became that the halocline doesn't just create beautiful sights, but also affects the movement of water, the lives of the inhabitants, and even the behavior of huge masses of the ocean. And from there, things get to a whole different massive level. When people talk about the boundaries between water layers, most imagine something stationary, like an invisible line, separating two parts. In reality, however, these boundaries are constantly changing, bending, and behaving like living things. This is especially pronounced in straits, where large masses of water collide. There, the current can flow in one direction at the surface, and at the same time in the opposite direction down below. From the outside, the ocean looks calm, even though a whole transportation system is operating within it. One of the most well-known examples is found where the Atlantic meets the Mediterranean Sea. In the Strait of Gibraltar, the water moves in two directions at once. The lighter water flows on top, while the denser water sinks back into the depths. This exchange happens around the clock without a break. If the water in all parts of the ocean were to mix instantly, many of the sea's unique characteristics would simply disappear. The temperature, salinity, and direction of the currents would look completely different. The entire planet would then take on a totally different appearance. However, even in those places where the boundary seems solid and stable, it is constantly changing its position. Waves can travel along it, but not the kind we're used to on the surface. These are invisible to the eye, deep underwater. Sometimes these internal waves grow to colossal sizes. A person standing on the deck of a ship wouldn't notice them, but underwater, huge hills and troughs of water, tens of meters high, are moving, developing very slowly. It's amazing that these processes can be observed, even indirectly. When an internal wave passes beneath the surface, the appearance of the water changes. The ripples look different, and long bands and patches with an unusual texture appear. Scientists have even learned to detect these phenomena using satellites. It creates a strange picture. A powerful wave is moving deep in the ocean, and its presence is given away only by a thin, almost invisible pattern on the surface. These processes are especially important in the northern seas. There, the tides collide with the uneven seabed and constantly force different layers of water to interact with each other. Without that energy, many deep-sea processes would happen very differently. The more researchers studied these phenomena, the more often they encountered an unexpected effect. The boundary between the layers affects not only the movement of the water masses, but also the buoyancy of objects within them. For a diver, this feels very strange. A few seconds ago, your body was holding steady at a certain depth, but after crossing the layer, it feels like someone secretly changed the weight of your gear. You have to adapt quickly, otherwise you could either sink deeper or, on the flip side, become too buoyant. This happens because the water around you stops having uniform properties. Similar phenomena are also taken into account when operating deep-sea vehicles. Equipment passing through areas with significantly different densities requires a preliminary calculation of its behavior. The ocean doesn't tolerate surprises. If the movement of water can confuse a person and their equipment, then, for living organisms, these boundaries represent separate worlds. This is precisely where the story takes an unexpected turn. One I absolutely did not expect to see. Usually, we think of the sea as one big, single habitat. There's the surface layer, there's the deep, and there are lots of different fish and other creatures. It all seems pretty straightforward and normal. Nevertheless, at the boundaries of these layers, conditions sometimes arise that are so drastically different from the rest of the environment that a special community of living things with its own rules and methods of survival. Some microorganisms live right in these transition zones and are hardly ever found above or below them. For them, this narrow layer between the waters becomes a whole separate universe. At the same time, the conditions are far from comfortable. There can be sharp drops in salinity, a lack of oxygen, and the presence of substances that would be poisonous to many organisms. But life, as usual, finds a way to adapt. There are organisms that literally team up for mutual survival. Some help deal with the harsh environment, while others provide protection and nourishment. This is how alliances are formed, without which life there would be impossible. Even these unusual communities seem insignificant compared to what scientists have found on the ocean floor. Because what comes next are places where the water isn't just divided into different layers, but forms truly separate worlds. In the depths of some seas and oceans, there are areas that seem to have appeared by chance, due to a mistake of nature. The researcher's vessel slowly descends, the beams of its lights slide along the bottom, and suddenly a shore appears, a real shore, right under the water. Beyond this shore, a lake stretches out. It has clear boundaries, a surface, and even small waves. The only difference is that it lies not on land, but on the ocean floor, under a mass of water that is itself part of another body of water. Phenomena like this are called brine pools. The water in them is so heavily saturated with salt that it becomes significantly denser than the surrounding seawater, which is why it doesn't mix and instead collects into separate bodies of water. When you watch footage from deep-sea vehicles, you get the impression you're looking at a lake in the desert at night. Only later do you realize that this is all happening at a depth where not a single drop of sunlight can penetrate. The boundary between the regular seawater and this lake is also a type of halocline. But the conditions here are very extreme, and most living creatures are completely unsuited for such an environment. a fish or a crab might accidentally cross this boundary. For them, this becomes a fatal mistake, since the high salinity and an almost complete lack of oxygen turns such a mistake into a deadly trap. That's why scientists constantly find the remains of animals near some brine pools. It paints a grim picture, as if there's a special graveyard at the bottom of the ocean where new victims periodically end up. But the most unusual part starts after that. Where it all ends for some life forms, perfect conditions are created for others to exist. Nature proves once again that it can't be judged from the standpoint of human ideas. Entire communities of mollusks and various organisms often form along the shores of these lakes. They use the substances that come from deep faults, building their lives around processes that are dangerous for most living things. When I first came across the facts about places like these, it wasn't so much the existence of underwater lakes that surprised me. By that time, the topic was already known for being unusual. What struck me much more was how thin the line between life and death can be. Sometimes this line is only a few inches thick. A little higher up, there's one environment, and a little lower, a completely different one. And all of this exists at the same time in the very same space. At the edges of the brine pools, researchers noticed another unusual phenomenon. The remains of organic matter settle there, slowly sinking and getting trapped in the transition zone. Over time, a unique organic ring forms. Scientists have unofficially nicknamed it the bathtub ring. Only here, instead of water stains on the sides of a tub, you find bacteria adapted to extreme living conditions. The deeper specialists delved into studying these ecosystems, the more often a question came up that had previously been almost ignored. Perhaps the halocline isn't just a result of natural processes, but an active participant in many of the phenomena happening around it. The boundaries between the waters can do more than just separate worlds on the ocean floor. They can concentrate substances, direct currents, and influence processes directly related to human activity. That's precisely why the halocline once turned out to be unexpectedly useful in a situation that was no longer about science or underwater discoveries, but about a very real, looming environmental disaster. When an oil slick forms on the ocean surface, it rarely maintains a uniform shape. Wind, waves, and currents start to stretch the pollution over vast distances. From a bird's eye view, this process looks like a living creature that is constantly changing its form. For a long time, it was believed that predicting the movement of such slicks was practically impossible. However, over time, specialists noticed a curious pattern. The oil often collected in the very same places. It turned out that the boundaries between different water masses act as a kind of trap. Water currents converge in these zones, and everything on the surface gradually becomes concentrated along a narrow strip. For the ocean, this is a normal physical process. But for ecologists and rescue services, it turned out to be a real gift. Instead of searching for pollution over a huge area, they can focus their efforts where nature itself directs it. During one major oil spill off the coast of Alaska, a significant portion of the pollution collected in exactly such a convergence zone. Specialists took this fact into account and were able to organize the cleanup operations much more effectively. A similar situation was observed in the Gulf of Mexico. There, the pollution stretched for a long distance along the boundary of different waters, but it remained relatively narrow. This shape made collecting the oil much easier. Later on, the data they gathered started being used proactively. Scientists would forecast the movement of water masses and calculate in advance where areas with accumulated pollution might form, even before the oil reached the coast. It turned into a pretty unusual situation, a phenomenon that most people had never personally witnessed, suddenly became one of the important tools in fighting environmental disasters. However, oil is far from the only thing that such a boundary can trap. Along with the water currents, the tiniest particles of sand and silt, as well as organic matter, constantly get swept in there. This is especially noticeable at the mouths of large rivers. There, the river water meets the seawater, and an area forms between them, where a huge amount of suspended particles gets held up for much longer than usual. Essentially, nature creates a massive filter. Everything the current carries over long distances gradually concentrates in certain places, changing the water's clarity and the distribution of nutrients. The existence of many living organisms depends on these processes. In some places, the amount of food for microorganisms increases. In others, the conditions for algae change. And in certain spots, entire food chains are restructured. It might seem like the halocline only affects isolated parts of the planet, like caves, river estuaries, and rare lakes on the ocean floor. But there is one area where its significance is much broader. We're talking about a region that plays a key role in regulating the climate of the entire Earth. It is there that the invisible aquatic boundary performs one of the most vital functions on the planet. When people mention the Arctic, the first things that come to mind are ice, polar bears, and harsh frosts. However, one of the most important characteristics of this region is completely invisible to the naked eye. It's hidden deep beneath the cold surface of the water. At first glance, this situation seems counterintuitive. In the deep layers of the Arctic Ocean, there are warmer and saltier waters that have come from other parts of the world ocean. It would seem that this heat should gradually rise up to the surface. If such a process were to happen freely, the surface would heat up much more intensely. Sea ice would form differently, and the entire climate of the region would operate on completely different principles. However, a barrier exists between the deep heat and the surface. It's not ice, not rock, and not an artificial obstacle. This barrier is created by the water itself, thanks to the difference in salinity between its layers. The halocline here acts as a kind of lid. It significantly limits the mixing of layers and prevents a substantial portion of the deep heat from quickly rising to the surface. You could say that every day, millions of tons of water serve as a gigantic insulating material. But this material is constantly in motion, changing, and remains almost invisible to observers. For the Arctic, this characteristic is extremely important. The process of sea ice formation depends on it, which affects the reflection of sunlight and a ton of processes far beyond the polar latitudes. By studying haloclines, scientists are increasingly concluding that the ocean cannot be considered a uniform space. Within it, there are layers with their own characteristics, currents, and their own laws. In some places, hidden internal waves are moving. In others, underwater lakes appear. And somewhere else, the future of sea ice and the entire world's climate processes is being decided. At the very beginning, we talked about billions of tons of water that touch but do not mix. Back then, it looked almost like a natural trick. Now, it is becoming clear that this is not an exception to the rule, but one of the mechanisms that makes the huge and complex system of the world ocean work. If you ever happen to see a photograph where two rivers with different shades merge, an unusual line in the middle of the ocean, or a video of an underwater cave where it seems like an invisible river is flowing, you will immediately realize it is not an optical illusion. You are looking at one of the most mysterious boundaries on Earth, a boundary located within the body of water itself. Perhaps this is where the main fascination with such phenomena lies. The more carefully we examine the most common and familiar things, the more often it turns out that they hide whole worlds that most people do not even know exist.